Hey IB Math HL students, in this video we're going to do a past exam question based on graph theory. In this question there are 4 different parts that involve first constructing a graph based on the layout of a room. Next we're going to calculate the transition matrix and powers of the transition matrix. Then we're going to find the steady state of the Markov chain, and then a final question, number 4. So let's get started.
In the first part, we're going to construct a graph to represent the information in this diagram, using vertices to represent rooms and edges to represent the connecting doors. I'm going to go to my graph theory app here, and now I'm going to construct the graph. I'm going to keep the layout similar to the layout in the image, so the vertex for the English room.
Okay, now I have vertices representing each of the rooms in the image, and then I'm going to construct the edges. So the edges are wherever there is an opening between 2 adjacent rooms. So there is an edge from English room to the art room, an edge. Get to the cupboard. Okay, so there we have our graph for this diagram. Now that our graph has been constructed, we can move on to part 2 of this question. For a prank, a student releases a monkey into the English classroom at 8:30 p.m. on Thursday. Given that the monkey wanders through the rooms at random, find the probability that the 7th room it wanders into after leaving the English classroom is the geography classroom. So in this case, what we want to do is, from our graph, we want to assign weights which represent the probabilities of moving from one vertex to the other vertex. We're going to use those probabilities to construct a transition matrix for the graph. In this case, we want to know the probability that the monkey ends up in the geography classroom on the 7th move. So once we calculate the transition matrix, we're going to calculate the 7th power of the transition matrix, multiply it by our initial state matrix, and then we'll get the probability that the monkey ends in the geography room on the 7th move. So the first thing I want to do is to construct my transition matrix for this graph. So I'm going to create a matrix. There are 9 rooms, so I need a square matrix with 9 rows and 9 columns. It doesn't matter the order that I assign the labels, as long as I am consistent in my usage of the matrix. Okay, so now the outline of my transition matrix is complete. I have in the same order, so the first row and the first column both correspond to the English room, and so on for the rest of the layout. When you're dealing with the transition matrix for a graph, it's important to keep in mind that the rows of the matrix represent your starting vertex, and the columns of the matrix represent your ending matrix, or your ending step after one move. So in this case, the weights of the transition matrix are the probabilities of moving from one room to an adjacent room. So if I were to start in the English room, so that's the first row here, I have 2 adjacent rooms I can move to, either the art room or the math room. So there's a 50% chance of moving from English to art and a 50% chance of moving from English to math. So from English to math, there's a 50% chance. From English to art, there's also a 50% chance, and I can't get from the English room to any of the other rooms of the school. Next, from the math room, I can get to either the English or the history room. So it's a 50% chance of going from math to English. Is also 0.5. Okay, and there we go. We have constructed our transition matrix for this graph. Now that our transition matrix has been constructed, it's time to compute the 7th power of this transition matrix. For this demo, I'm going to be using a TI-84 calculator. So what we want to do is we want to input the rows and columns of a 9 by 9 square matrix and then compute the 7th power. So on my TI-84, there is a matrix button here on the left-hand side. It's in blue, so I'm going to click on the second button and then on matrix. I'm going to move over to edit, and then I'm going to edit the first matrix A here. I'm going to put in the dimensions. It should be 9 by 9. Hit enter. And so now our next step is to input all of the values for this matrix. Okay, now I have inputted all of the values for my transition matrix into matrix A. So the next step is we're going to compute the 7th power of this matrix. And also the question asked, if we start in the English room, what is the probability that they end in the geography room on the 7th move? So for this, I need a matrix representing my initial state. So I'm going to, again, press the second button, click on matrix. I'm going to go over to edit, and then my initial state matrix is going to be matrix B. Hit enter. So for an initial state matrix, this is going to be just a row matrix. So it's going to have 1 row and 9 columns. And this matrix represents the probabilities of my starting positions. I already know that I'm starting in the English room. So there's a 100% probability of being in English, and there's a 0% chance of being in any of the other rooms. So now I've inputted my transition matrix and my initial state row matrix. The next thing that we want to do is to calculate the product of the row matrix on the left-hand side with the 7th power of the transition matrix on the right-hand side. So I'm going to exit out of this. I want to select first my initial state matrix. So I'm going to press second, matrix, and then it's going to be matrix B. Hit enter. And then we're going to have times. And then in parentheses, I'm going to go to second, matrix, matrix A, close parentheses, raised to the power of 7. Hit enter. Okay, here we have our answer. Okay, so what we want to do, we want to find the probability that the monkey ends in the geography room. So we're going to go back to our transition matrix and figure out where the geography room is. So in this transition matrix that we constructed, the geography room is the 8th vertex, or the 8th column. So I want to look at the 8th value of this answer. So in order to view all of the results for this answer, I'm going to store this answer into a third matrix C. So down here I have this answer button above the hyphen. I'm going to click second and then answer. And then I want to store this into a matrix. So here is the store button. I'm going to give it the name of a matrix. So I'm going to choose matrix C. I'm going to hit enter. So now the results of this computation are stored in matrix C. I can then go back to the matrix, so second matrix, go over to edit, view matrix C. And so the geography room is the 8th column, so the second to last column. We can see that there is an 11.06% chance that on the 7th move, the monkey ends in the geography classroom. Now we've found the probability that on the 7th move, the monkey ends up in the geography classroom. That was an 11.06% chance. On to part 3. The monkey continues to wander through the school building all night until the cleaner arrives at 6 a.m. on Friday morning. By inspecting the steady state probabilities, write down the room in which the cleaner is most likely to discover the monkey. So in this case, there are two different approaches we could use to solve this problem. In the first case, so what we're trying to do is we're trying to find the steady state of this Markov chain. So what that means is I want to find an eigenvector whose corresponding eigenvalue for this matrix is equal to 1. That means for whatever starting position I'm in, given those probabilities in a row matrix, if I multiply it by the transition matrix, the probabilities remain the same. So the first method, I could use eigenvectors and eigenvalues to calculate the steady state of this Markov chain. That might be a little bit time consuming. On the other hand, what we can do is, assuming that there is a steady state for this matrix, we can just calculate a high or a large power of the transition matrix and then use that as our steady state matrix. So in this case, what I'm going to do is I'm going to start with my initial state matrix. So that was 100% chance of being in the English room. I'm going to multiply it by a large power of the transition matrix. So I'm going to exit out of here. So I'm going to go to matrix B. So this is our initial state matrix. And then I'm going to multiply it by a large power of the transition matrix. And for the power, it doesn't necessarily matter what we use. I think 100 should be sufficient for this case. So I have my initial state matrix, 100% probability of being in the English room, multiplied by a large power of our transition matrix. Then we're going to wait for this to compute. We get our answer. And then if I want to be able to see the probabilities more clearly, I want to store this into another matrix. So I'm going to go to second, answer, store. I'm going to give it the name of matrix D. Press enter. The answer is stored into matrix D. I'm going to go to the edit view for matrix D to view the results. And so what this represents is after a sufficiently large number of moves, the final positions or probabilities of the positions of the monkey. So what I want to do is I want to find the room where the monkey has the largest probability of being in. So I'm going to look for an entry that has the largest percentage. So I've got 17% is the highest so far. Okay, so it looks like around 17% is the largest probability appearing in this matrix. So that corresponds to the third column. And from our transition matrix, that was the art room. So that means that the monkey is most likely to end up in the art room by the time the cleaner arrives. All right, let's recap what we have learned so far. So we are given the layout for a school. Our first step was in constructing a graph representing the layout. So here we had our graph. If I wanted to elaborate on the graph, I could make this a directed graph and assign the probabilities as the weights to the directed edges. The second step, we constructed a transition matrix. So our transition matrix had 9 rows and 9 columns. The weights of the matrix were the probabilities of moving from one room, represented by the row, to another room, represented by the columns. We used this to calculate the 7th power of the transition matrix. We multiplied that on the left by our initial state matrix being in the English room, and we found the probability of being in the geography room. Next, we calculated the steady state of this transition matrix. We did that by estimating it with a large power of the transition matrix and multiplying it on the left-hand side by our initial state. Finally, we're on to question number 4. Stating clearly any assumptions you have made, find an approximation for the total length of time the monkey is likely to have spent in the math classroom before the cleaner arrives. So for this question, I'd like you guys to try this one on your own. Let me know what you guys think the answer is down in the comments below, and thank you for watching.